All right, guys, today we are going to just expand a little bit more on what we did over the weekend. And we're going to be talking about more derivatives, and we're just adding in constant, sum, and difference. So it's essentially what you were doing before, we're just adding a little bit more. The derivative of a constant function is always 0, and that is the first thing we need to know. And let's think about this in real life, and I'm actually going to plot point A I'm going to actually plot example A on my graph here. If you have the graph of a straight line, right, like y equals -4, that's going to look like this. And I ask you, like, what is the slope? So we know derivative is instantaneous slope. So if I have a straight line or a constant, then I'm asking, like, what is the slope of this line? The slope of any horizontal line is 0. And you can say that here. Slope of any horizontal line is 0. So remember, if we have a constant right here that is like, let's call that 3, I know that my slope is 0. Therefore, y prime equals 0. Now, the other thing to think about here is that, like, if you were doing like some sort of subtraction here, right, there's no x variable, there's no exponent to be able to subtract, right? So like we're just saying that the slope of a constant line is 0. So right here I'm going to say s prime of t is 0. F prime of x of 0 is also 0. And then right here, y prime equals, whenever we see pi, a lot of times we want to think like, oh, pi, there's a variable, right? Because it's not a normal looking number. But remember that all of these guys right here are still going to be constants. So in this situation, we know that k is going to be some sort of value, right? Pi is about 3.14, and then 2 is 2. So if you have a number times 3.14 all divided by 2, we know that the derivative is going to be 0. Next, we'll talk about our single variable rule. And then all that we're saying here is the derivative of any single variable is going to be 1. So let's look at the line y equals x. Remember that we know that the derivative is the average rate of change. So how are we moving? Up, over, up, over, up, over. We're going up 1 over 1, up 1 over 1. So that means that the derivative of this is just going to be 1. Same thing here. And remember, if we're thinking about, like, we have 1x to the 1, we're pulling that down and multiplying. So we have 1 times 1 x to the 1 minus 1. This makes this 1 times x to the 0, which cancels out, and we're just left with 1. So same thing here. S prime of t, it just equals that coefficient, which is 1. And I'm going to change this up a little bit right here. I'm going to say x of t, let's say that this is 4t. If I were to take the derivative here, it would not be 1, it would be 4. Because that variable would go away by taking it down a degree, and we would just be left with that coefficient. Last new thing are the sum and difference of the derivatives. And the sum and difference of the derivatives just state that if you're taking the derivative of f of x plus g of x, it's just the derivative of f of x plus the derivative of g of x. Same thing for the difference. There's no kind of funky rules or like expansion that has to occur here. If we just have plus signs, no multiplication, no nothing, then we just take the derivative of each one. So let's use the sum and difference rules to find the derivative of the following. For letter A, I'm going to say f prime of x equals, remember we're pulling that 3x squared, minus that 2 comes down, 10, take it down a degree x, plus 2 times 1 is 2, take the degree down, so you're just left with 2. And remember, the derivative of a constant is 0. So we are done. I am going to have you pause the video right now and answer number 5. So please press pause and answer number 5. Take a look at your answer here. Remember, we're multiplying 2/5 by 5, so that's just left with 2. Take it down 1 degree. That 4, we're multiplying that by 1, take it down a degree. 2 times 3, take it down a degree. Constant is 0, so there's nothing there. Let's look at g of x really fast because he's a little bit funkier. I'm going to rewrite this as x to the 1/3 plus 5x to the 1/2. And that's going to help me out when I am taking the derivative here. So when I do g prime of x, multiplying, so we have 1/3, subtract, so we're subtracting 3/3, multiply, so that's going to be 5/2, subtract, x to the negative 1/2. We can keep it here unless it asks for our exponents to be rationalized. Remember, rationalized is positive exponents. So if I were to rewrite this and it asked for it to be rationalized, I would say 1/3x to the 2/3, or the cube root of x squared, plus 5/2, and that's either the square root of x or x to the 1/2. It doesn't matter. I'll just do that so you get a different representation. Both of these answers are okay unless specified. I'm going to give you guys a second. Please pause and do letter D on your own. Guys, checking in with letter D, I have a few answers here. You can do square roots, remember, or you don't have to. So checking in, remember that the square root of x is also written as x to the 1/2. Also remember, oh my goodness, I put that in the denominator. I'm fixing that right now. Whoopsies. This is what happens when you write sloppy sometimes. We can do a square root of x, or we can do x to the 1/2 in the numerator. Then you have minus 10, and that's going to be x to the 2/3, or the cubed root of x squared. And then we have minus 4/x squared. Let's go over F really quick, and then I'll drop in the answer to E just in case you wanted more practice with that number D. We'll come back to that at the very end. For part F, let's divide everything by x first to get rid of that. We will learn about this new rule later on, but for right now, let's not make it more complicated than it has to be. F of x is going to be the same thing as 8x squared plus 4x minus 3/x. I'm going to rewrite that, and I'm going to change that 3/x, and I'm going to make that 3 times x to the negative 1. Now I'm going to use my sum. I'm going to use that rule, and we're just going to derivate here. 2 times 8 is 16, and then remember we're taking it down a degree. 4 times 1 is 4, and that just stays here. That negative 1 comes down and multiplies by that negative 3 to make that a positive 3. Subtract 1, so x to the negative 2. And then we're always taking that down and summarizing at the end. And I'm going to say f prime of x equals 16x plus 4 plus 3/x squared. If you are feeling super confident about answering E on your own, then you are done. If you want to stay on, I will go through the explanation for E. I'm going to rewrite it first and say h of x is 3x squared minus 4x to the negative 2 plus 2x to the 1/2. So there's step 1. Step 2, let's take this and start derivating. H prime of x equals 6x plus 8x to the negative 3 plus 1/2 times 2 is 1, x to the negative 1/2. Now we're just rewriting with those rational exponents, and I'm going to say h prime of x is going to be 6x plus 8/x cubed plus 1 over, you can say square root of x or x to the 1/2. It does not matter. They mean the same thing. Remember that the denominator becomes that root index, And on a square root, that 2 is implied, so we don't need to write it. And that numerator of the exponent fraction is the exponent on there. And again, if we have x to the 1, we do not have to write it. It is implied. So box your answer, and you are done.